Okay, we start with an example. Let's say Xenia. Xenia is 10 years old and Yonin is 12 years old. Okay, so this year. The next year, Xenia will be 11 and Yonin will be 13. And the next year, Xenia will be 12 years old and Yonin will be 14 years old. If we use X to represent the age of Xenia, use X, and Y, the variable Y represent the age of Yonin. So what is the relationship between X and Y? As you can notice here, Yonin is 2 years older than Xenia. So you can use Xenia's age, add it 2. It will be the age of Yonin. So X plus 2 equal Y. This is the equation explain the relationship between X and Y, which is the age of Xenia and Yonin. Whenever, so if I tell you now Yonin is 40 years old, what is Xenia's age? So you know X plus 2 equal Yonin is 40, so you know X equal 35. So you can use this equation to, if I know one of the variable, I can use the equation to find the other one, the value of the other one, right? Okay, here is another example. This is a number of cars and the number of wheels, right? Okay, you have one car. If I have one car, it should be a car has 4 wheels. Okay, I use X to represent the number of cars and use Y to represent the number of wheels I have. Can I say X plus 3 equal Y? No. The reason is if I have 2 cars and I should have 8 wheels. If I use this equation, when X equal 1, that makes sense. 1 plus 3 equal 4 tires, the 4 wheels. But when X equal 2, that means I have 2 cars plus 3 equal 5. But actually 2 cars should have 8 wheels, not 5. So I cannot use this equation to represent the relationship between X and Y. So the correct relationship or the correct formula, the equation, it should be 4x equal y. So you use the number of cars, multiply 4, you will get the number of wheels. So if I have 10 cars, 4 times 10 equal 40. I should have 40 wheels. So 4x equal y should be the correct relationship between the cars, number of cars, and the number of wheels. Okay. Then let's have a look at the more complicated one, right? So this is R and M. What is R and M? R is the number of rectangle. Okay. For example, this is 1. This is 1, 2, 2, not 2 rectangle. 1, 2, 3, 3 rectangle. And the number of matches from here, 1, 2, 3, 4, 5. Oh, I'm wrong. So you count the bottom one as well. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So 11 matches. Okay. And if I have 2 rectangle, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 12, 13, 14, 15, 16, 17, 18, 19, 20, 20, 21, 22. So 22. If I have 3, if you count, that would be 33. So you notice the number of R and M. You just multiply 11. R multiply 11, you will get the number of matches. So the relationship is M equal 11R. Okay. How to count 33? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30, 31, 32, 33. So 33. Okay. So let's have a look at the other example. So T and P. T represent the number of triangles. P represent the number of matches again. A perimeter. Oh, the perimeter of the diagram. So with one triangle, the perimeter is 3 units. 3 units. 1, 2, 3. Okay. Triangle 2. 2 triangle. So the perimeter 1, 2, 3, 4. Okay. The perimeter only count the length, the segment outside, not inside, not this one. So there will be 1, 2, 3, 4. So 4. If I have 3 triangle, 1, 2, 3 triangle, the perimeter is 1, 2, 3, 4, 5. So it's 5. So what is the relationship between P and T? You notice the P is always T plus 2. Right? So you can say P equal T plus 2. Okay. That's it. Okay, have a look at the D. D use also found links between the number of triangles and the matches together. So how many matches? So again, I have 1, 2, 3 triangles. When I have one triangle, I use 1, 2, 3 matches. When I have 2 triangles, I use 1, 2, 3, 4, 5 matches. When I have 3 triangles, 1, 2, 3 triangles, I use how many? 1, 2, 3, 4, 5, 6, 7. 7. So this one is more complicated. It's more difficult, you found. Because first you notice the differences between 1 and 3 is 2. And second is 2 and 5, so the differences become 3. And the third, if I have 3 triangles, then the number of match will be 7. So the difference becomes 4. So the difference is changing. So I cannot say P equal T plus something, right? However, you can see each time when T increased by 1, M increased by 2, by 2, by 2. Okay? That means you should put the coefficient of T2. Because when T increased by 1, M increased by 2, then you should put the coefficient of T2 here. But if you only write M equal to T, M equal to T, your number will become when T equal 1, M equal 2. When T equal 2, M equal 4. When T equal 3, M equal 6. Because M is double T. But now our sequence is here. Now our number is 3, 5, 7, 9. But I got 2, 4, 6. So how can I do? I plus 1 here. So everyone plus 1. 2 plus 1. 4 plus 1. 6 plus 1. So it becomes 3, 5, 7. So 3, 5, 7. Got it. So this is the equation I want. So this is the correct one. Let's have the last example here. How many squares and the pyramid again. So when I have 1 square, that's 1, 2, 3, 4. When I have 2 square, that's 1, 2, 3, 4, 5, 6. So the 6. When I have 3 square, 1, 2, 3 square, the pyramid is 1, 2, 3, 4, 5, 6, 7, 8. It's 8. Okay, first you see the differences between 1 and 4 is 3, and 2 and 6 is 4, 3 and 8 is 5. So the difference is changing. And you notice when S increased by 1, P increased by 2. When S increased by 1, P increased by 2, you put the coefficient of S2. But if you just write P equal to S, there will be S when S equal 1, P is 2. When S equal 2, P is 4. When S is 3, P is 6, because P is double S. You double S to get P. But the numbers P here is 4, 6, 8, not 2, 4, 6. So I added 2. This is not 25, it's 2S. It's 2S. I'm sorry. So you added 2, added 2, added 2, and you get 4, 6, 8. Bingo, you got correct number. So P equal 2S plus 2 is the correct answer. Okay, that's it.